Welcome to my YouTube channel, and this is our first video in our journey for discussing mathematics, and we are going to look at the specimen for 2016 paper 2 question 2b, which has to do with vectors. Like I said earlier on in my previous video, that drop your comments about the videos I'm going to be producing so that I can develop also in certain areas which you the viewers will feel like I'm not delivering. So this question, as it reads in the diagram below, AE is equal to vector P, AD is equal to vector Q, AE is equal to EB, that means that those are straight lines, AD is equal to DC, DE is parallel to CB, and CF is to FB, as the ratio is equivalent to 1 to 3. And there is a diagram which you can see. Then the questions for this particular question follows: express in terms of P and slash Q. That slash means O, meaning the answers which you are going to write for DE, EC, CB, it's either we can find an answer whereby there is just P alone, or there are answers which you can find where there is both vector P and vector Q. That's why they put that. Those are possibilities. And for the second question, show that vector EF is equal to half, in brackets 3 vector Q minus P. Now, in mathematics, you really have to make sure that you pay attention to the information which has been given. Like there is an information, this question, which has been given, meaning we have to make sure that we make use of whatever they've given us in the statement. We can't just start working out the question even if we know how to work out the vectors. We really have to make sure that we understand the statement. Okay, so now with the questions which you have been given, in order for us, I've actually just written down all the answers, and then I'll explain on how everything was coming out to be the way. Alright, now continuing, you can see that they asked us to find ED. Now when you look at the diagram, D to E is this arrow, and we have been told that this line DE and CB, they are parallel. We have also been told that AE and EB are equal because of these lines. You can see them. And then again, we can see that AD and DC, they are also equal. So because of these two lines, you can see that. So now, they have asked us to find DE. Now, how do we do it? For vectors, these two letters are the guiding principles. These two letters, D and E, are the guide. Because from your formula, it means that you have to start from D, and then you are ending on E. If there is no arrow here as a vector, you're going to find that DE is as good as the distance. You're moving from point D to E. Now, for vectors, you are going to realize that instead of you using a direct route, like in here, you can see that you move from D to E. Instead of moving direct, you have to use a longer route. Either you move this way or the other way. But again, you have to choose. We can't go all the way to C, B, and then we go to E. That would be just too long for us. So we are just going to move from D to A, and then from A to B. Now the arrows are very important because the starting point for this vector is from A. So we have to observe the arrows. Anything which is moving against this arrow has to be the opposite, and the opposite of positive, it's negative. So we move from D to A plus A to E. Like I said, these letters are the guide. They have to be the outer letters as we work out this problem. Now DA, when you look at DA, it is moving against the arrow for AD. It means that DA is the opposite of AD. And since AD we have been given that it's vector Q, what are we supposed to do? We are going to put it as negative AD plus AE. Then we substitute AD, we know that it's Q. We substitute with Q, so it gives us negative Q. This is the solution. But for clarity's sake, we need to rearrange them and then we keep the negative sign in between. From here, we move on to EC. EC, again, the guiding principle here is that we have to start from letter E and then we end on letter C. So for the formula, you have to move S from E. When you look at our diagram, we are going to move from E to A, and then from A to what? Letter C. Have you seen? Again, we have got another option where we can move from E to B and then from B to C. But the question we have to ask ourselves, do we have BC? No. And since we don't have BC, this BC, we don't have it, luckily with us, for us here we have AE. We also have AC. So that's the route we are going to use. So I'm going to start from E to A plus A to C. Go back to our formula here. Now again, when you look at EA, when we get back to the diagram, we are going to find that EA is moving against this arrow for AE. So it is the opposite of AE. So it will be negative AE plus this maintains. It's not the opposite of anything, this maintains. Negative AE plus AC, this maintains. So from here, we know that AE, what is our AE? So we get back to our diagram. AE is vector P. So we substitute. Where there is AE, we just put P, and then the negative maintains. Plus, what is our AC? We check AC. Here we have been told that AD and DC are equal. So if from the point A to D it's Q, it means that even from D to C, it has to be Q. So Q plus Q, using algebraic expressions for like terms, it is going to give us 2Q. So therefore, where there is AC, we substitute with 2Q. Rearranging this, it is going to give us 2Q minus P. So that is the solution for EC. Then, we go to the next question, C, which is CB. Now, what is CB? Again, these are the guiding principles. We are moving from the point C to B. So when we get back to our diagram here, you are going to see that we are going to move from the point C. Now, again, C, we can't move direct from C to B. Because for vectors, we have to use longer routes. We can use any other way, but starting from C, from the point C. So here, I don't have, so from here, myself, I picked this route whereby I move from C to A, and then from A to B. There is also another route which you can use. You can move from C to E, and then from E to B, because EC we have it. So you can also use that route. So C to A. What is C to A? When you look at C to A, this is moving against the arrow for the vector from A. So if AC is 2Q, it means that CA is going to be the opposite of AC. Like from our formula, CA plus AB, but this is the opposite of AC, so it has to be negative AC plus AB. Now we substitute for AC. So we go back to our diagram. What is our AC? Our AC is Q plus Q. It gives us 2Q, but here there is negative, so it has to become negative 2Q plus 2P. From here, we rearrange them. It gives us 2P, which is 2 vector P plus 2 vector Q. That's our solution for CB. Then, now, we've been told that we have to show that EF is equal to half 3Q minus P. So we can check from the question. So now, when we start, we have to move, we go back to the same diagram again. Where is our EF? You check, oh, E is here. And where is our F? F is here. So how can I move? Here there are options whereby we can move from F to C, then from C to E. Or we can move from F to B, then from B to C. But the bottom line is that where we are starting from, which is F, and we are ending on what? E. So now, Remember from the statement I said that earlier on that when you are given a statement, it is very, very important for you to understand it and read before you start answering and understand it. So in that statement, they gave us the information about the ratio CF to FB. Now, when you look at this EB plus BF, we cannot find this minus us having BF. Do we have BF when we get back to this? From the answers which we have here, for DE, for EC, for CB, we don't have the solution for BF. So now, what is our BF? BF, when you look at it on the diagram, BF is the opposite of FB. And on the ratio here, we have been given that the distance now from C to B, the whole of this length, CB, its ratio is 4. That's the total. But it has been split into whereby they've given that CF is 1 and FB is 3. So what do we do? FB is equal to, the ratio of FB is 3 out of the total ratio, which is 4, of the length of CB. And we do know that in mathematics, of implies multiplication. So from this point, we can see that 3 over 4, more in brackets, we know what is our CB. We go back. We found CB to be 2P minus 2Q. So we substitute 2P minus 2Q, and then multiplying 3 over 4 times 2P, 2 into 2, 1, 2 into 4, that gives us 2, so it remains with 3 over 2P minus, again, these 2 divides 4, we remain with a 2, 3 times Q is 3Q over 2. That gives us our FB. Now we go back to EF because that's what you are finding. Oh, EF is here. Oh, EB plus BF. What is our EB? We get back to our diagram. Our EB, AE is P, and these symbols implies that the length from A to E and the length from E to B is the same. So if here is P, then even this side it's P. So EB is going. All right. So now we get back to the diagram. EB. So EB. When you look at this arrow, it is showing us it's moving. This vector is moving from A to B. So meaning EB is just going to be P, positive. So EB plus BF. Now again, when we get back to the diagram here, BF. BF is the opposite of FB. Have you seen? So it means that our BF here has to be negative of FB. We have to be very careful because once we miss out this point, it means that we are going to have everything wrong. So EB is P minus, what is our F? Our FB, we found it earlier on here as this. Yes, so we had it here. So where there is FB, we substitute because FB we know that it's 3 over 2P minus 3 over 2Q. So we substitute here. It's here. Then we multiply negative times this, it gives us this, which is negative 3 over 2P plus negative times negative, that's positive 3 over 2Q. These vector P and 3 over 2P, they are alike terms. So we look for a common denominator here, which is 2. 1 into 2 times P, that gives us 2P minus 2 into 2, that's 1. 1 times negative 3, that gives us negative 3P plus 3 over 2Q. So from here, when we group the like terms, we add them, we are going to get negative half P plus 3 over 2Q. Rearranging it in order, it is going to be 3 over 2Q minus half P. Now, we have been specifically left the solution in a form which we need to arrive at. This is a solution in cases whereby you have not been restricted to produce a particular answer. But in this case, they want us to produce a particular answer. So what are we supposed to do? We factorize here. 3 over 2 is as good as, 3 over 2 can be written as 3 multiplied by half. So I mean we can factor out half. When you look at this expression on both sides of 3 over 2Q minus half P, we have got a common factor, which is 1 over 2. So we can remove it outside, which becomes 1 over 2. Multiplied by here, we are going to remain with 3Q minus P. and then that means that we have showed the solution we wanted. I hope this this video has been a bit insightful. Like I said, please drop any comments, anything which you have seen that maybe you have not understood. You can ask me any questions via the comment section. I would like you guys to help me develop this platform so that it can have a larger audience. So I would like to hear from you, your comments, and anything which you saw didn't go well in this particular lesson, or maybe the video. If there's anything, my handwriting, anything, please feel free to drop your comment and subscribe to my page, because there's more of these lessons which are going to be dropped on this particular platform. Thank you for watching.